In example one, all we really did was take a look at our rule that we were given and we applied that rule to that expression. So again, I'm going to do the same thing here. So I'm going to take my numerator, which I'm going to highlight here highlight that in pink, and my denominator, I'm just going to highlight here in green. And I'm going to apply the rule that I have up here. I can kind of see the rule highlighted in the previous example. So if I want to find the derivative function, what I'm going to do is I'm going to differentiate the numerator. So I'm going to end up with 1 over 2 square root x, and that's going to be the derivative of the numerator. I'm going to multiply that by the denominator undifferentiated, so it's just x squared plus 1. I leave that alone. And then the next part of that derivative is going to be just leave the square root by itself and differentiate the numerator. So x squared plus 1 just becomes 2x plus 0. So I'm just going to leave it as 2x. And then once I've done the numerator, there's no more differentiating involved. We just take the denominator of x squared plus 1 and we apply that, we square that, and that's part of the formula. So again, all I've done then is I've applied the formula to get the derivative. So then I want to simplify this. So one way to simplify this is I've got a root x here in the denominator. Over here, I've got a root x in the denominator, so I kind of want to get rid of that. So I'm going to multiply by root x. And I think I'll get rid of the divide by 2 at the same time. But I need to do that to both top and bottom. Otherwise, I'm going to change the value of that fraction. So I'm going to apply that to the numerator so that 2 root x cancels out. So I'm just left with x squared plus 1 minus, when I multiply this together, well, I'm going to end up with 4. Root x times root x is x. And then I have the original x from the 2x. So I'm going to do that. I'll just show that in green. That's from the original 2x. And so this actually gets rid of that mixed, kind of more complex fraction with roots in the denominator. It does put this 2 root x term in the denominator, but at least it's not a fraction inside a fraction. So then I'm going to end up with 2 or x squared plus 1 all squared. I don't really want to mess with that denominator because it's already in factored form, and we just want to keep things factored in fractions when we can. I'm going to combine my x squared terms that are generated in the numerator. So I end up with 4x squared, and that's all over 2 root x, x squared plus 1 all squared, and then this simplifies to 1 minus 3x squared over 2 root x, and then x squared plus 1. There are no common factors, so that's as low as I can go. That's as simple as I can go. And again, notice that I left the denominator in factored form because we generally want to keep those in factored form.